Welcome back to the Decarb Connect podcast. And this week, I'm really pleased to be joined by John O'Donnell, CEO of Rondo, who recently joined me on site in Houston. So lovely to be connected with you again, John, and very pleased to have you in the guest chair today.
Thank you, Alex. It's a great pleasure.
So we're going to be talking about the problem of industrial heat. And just as a very, very brief intro, and then I'll ask you to give a bit more background. The reason we're talking about this is because Rondo is bringing this really interesting technology and approach to market, which is the use of heat batteries within industrial processes, which is really going to be one of these things that enables a much more dependable and wider use of renewables in industrial processes, which typically there's been a lot of pushback and a lot of challenges in making that viable as a route for decarbonization. So I think a really interesting technology and an interesting problem for us to unpick today. So John, why don't you give me this sort of the sense from you of how you've arrived at this point in time. So tell us a bit about you and about Rondo and where we are at this point in time.
Sure, thank you. Yeah, that was a perfect introduction in that industrial heat is perhaps the greatest challenge in total decarbonization that has not yet been grappled with. For myself, I was always fascinated by energy. I was originally a computer scientist, but I took my first job at a nuclear fusion research lab, and a fellow who's my boss's boss now is overseeing ITER for the United States. And the fusion program has only had 60-year schedule slipped in the interim. I built companies in the computer industry and in the semiconductor industry. Along the way, I wound up with a couple of machines in the Computer History Museum. But in 2005, I wound up founding the first of a couple of solar companies focused on bringing transformations to the cost of renewable heat. Both of those companies were companies that directly used sunshine to make steam with mirrors and receivers. And one of them went on to deliver more than half of the solar industrial heat that is running in the world today, but a drop in the ocean. There are many challenges with those direct solar to heat systems, but the most profound change that happened over my career in solar thermal, as they call it, or concentrating solar, was that the cost of wind and solar electricity dropped by 95%, which opened a completely new way of addressing industrial heat if one could capture intermittent electricity and put it to this purpose. Wind and solar power have become the lowest cost forms of energy that humans have known since civilization began. That is a profoundly wonderful thing. Energy is what lifts us out of poverty and transforms the world. And the notion that we are now in an era where intermittent electricity is lower cost than any fuel in most places in the world, and for sure as we go forward, everywhere in the world, they're becoming lower cost, creates an opportunity to solve not only other problems in electricity, but this giant problem as well as industrial heat. And that's what we put Rondo together to do.
So the starting premise for this conversation, which Rondo kind of neatly matches into, is that industrial heat is overlooked as a problem. So let's start there. So why is it, do you think, that it's been so overlooked before? And tell us a bit from your seat about what's the market opportunity look like for the companies that can really tackle it and tap into it?
Yeah, thank you. Overlooked is an excellent term. I think if you went around and asked people about the big challenges in California for decarbonization, I'm speaking to you from California, or many places, unless you speak to certain policymakers, it is absolutely underlooked. California burns more natural gas for industrial heat than it does for electric power generation. almost nobody knows that. Industrial heat is the single largest use of natural gas in Europe and the UK. Again, almost nobody knows, very few people know that. And, so it is a giant consumer of energy, making all the commodities from baby food to cement to fuels to everything we use every day. It's a giant use of energy, and it is kind of invisible to many people. And it is an industrial energy writ large. The heat portion, 3/4 of all the energy used by industry worldwide, is in the form of heat, not electric power. And you asked about size. I look at it from the renewables perspective. There are many ways of looking at it, but this year the world will cross 1,000 gigawatts of wind and 1,000 gigawatts of solar installed before the end of the year, they say. The IEA wrote a report on industrial heat a few years ago, and their number, if you do a units conversion, says we're going to need to build 9,000 gigawatts of new generation to just replace the heat that's used in industrial processes today. And of course, as the world becomes wealthier, our economy, all of our economies are growing, so that industrial heat demand for sure is rising. So if one could repower industrial heat with renewables, it's a multi-trillion-dollar market for the energy storage systems and a tens of trillions of dollars market for the renewables themselves.
This is a huge opportunity, and at the same time, I know from the industrials in our network and some of those on site that you'll have met, John, there's still this sense that renewables is maybe an element of their solution that they could use for site-wide electricity or something, like, rather than for the actual core energy intensive process. So tell me what's your sense of, like, what are the industrials starting to believe that renewables really could be an answer to this core issue of industrial heat, or are you still finding that you're kind of knocking at a challenge when you talk to them about that?
Yeah, that's a wonderful question, because of course the pathways that folks are vigorously pursuing have been exploring. What are the pathways? There are things like biofuels, but unfortunately they're many times more expensive than conventional fuels and available in very small fraction of world energy could be supplied if every possible biomass energy resource were deployed. There are carbon capture pathways, which for sure create permanent higher costs of doing business. Perhaps the biggest tap into renewables have been hydrogen pathways, where we can capture intermittent electricity and convert it to continuous high temperature heat. But unfortunately, with fairly expensive kit for doing the electrochemistry of electricity to hydrogen, and only about 50% efficiency. That is, it's about 2 units of electricity per unit of heat if you're combusting hydrogen. So I think it's been a fair assessment that, look, renewables may have a role, but they're much more expensive, because if you need twice as much electricity per unit of heat, the economics just aren't there yet. Only a couple of years ago, the notion that you would use electricity as your source of heat would sound crazy, because the speed of decline in cost in renewables, most people aren't quite caught up. You have to look carefully at this year's prices or last year's prices. It's only in about the last 3 years that we have entered this era that intermittent renewable electricity is cheaper than business as usual. So that's the first key thing you've got to get your mind around. And then the second is, of course, how do I use it? I can hook up a solar field to the substation where my factory operates, and the solar field will be automatically backed by the grid. Integrating renewable electricity has its challenges, but it is well understood. I can't take that same intermittent electricity and somehow hook it up to my industrial process. That process has to run dead level, and it has very tight process constraints in temperature, energy flow, and safety. Rondo has built a fundamentally new tool in the toolbox to do just that, to take that intermittent electricity source and convert it not at low efficiency, but at very high efficiency to continuous heat using a couple of century-old technologies. We had a breakthrough recognition after maybe design revision 80 in how to use century-old materials in a fundamentally new way to solve that problem. So to your question of, do people know it yet? No. And thank you for the work you're doing broadly in bringing together folks who are struggling with decarbonization, because there are lots of different pieces to the problem, and I'm thrilled to be talking to you about our piece of it.
So let's look at where you fit into this, because obviously we're talking about this wider field of renewables, solar in particular, but that is not specifically where Rondo plays. You play at this point of the actual heat battery. So tell us a bit about that. You know, what it's always hard in an audio podcast to give a feel for what this looks like. But if you were going to paint a visual picture for listeners, where does your technology fit? If you imagine it, you know, there's a kiln that we're trying to channel renewables into. Where does this tech fit?
That's a great question. And let me pull out the whiteboard here and I'll stick it through the audio stream. Let's go step by step. First of all, electricity to heat. Your toaster, your hairdryer convert electricity to heat at 100% efficiency. They use heating wires made from an alloy that's been in use for 100 years, and they last decades, and they deliver heat. The heating wires are at quite high temperatures, far higher temperatures than have been achieved by any energy storage system that is currently in use. Of course, those heating wires are only hot when electricity is flowing through them. So we have a technology for converting electricity to heat at 100% efficiency. And the same is true in any electric oven. Now, there's another century-old technology, in fact, a couple of centuries old. The steel industry has been using heat storage at blast furnaces to reduce the coal consumption per ton of steel by arranging giant towers of brick. And at any moment, the exhaust from the blast furnace is blowing through one of those towers, heating thousands of tons of brick. And the inlet air to the blast furnace is being drawn through another tower, being superheated before it enters the furnace. In 1828, the technology was introduced as a coal saver. Rondo found a way to combine those two century-old things in a means so that those electrical heaters directly radiantly heat the brick, just the way they radiantly heat the toast in your toaster. And we heat brick to well over 1,000 degrees Celsius, and then pull heat out of the brick exactly the way that the blast furnaces do, by circulating air through the brick to deliver superheated air, which can now flow into things like a cement kiln or a cracker for high temperature cement and chemical manufacturing, or drive boilers for a very wide range of industrial processes. So we're working with completely conventional systems and materials. We were selecting for how do we go fast to very large scale. And if we want to do that, we must use earth abundant materials that don't have supply constraints. Brick is made from dirt. You burn dirt in a kiln and you get brick. The heaters are made from an iron alloy. We have succeeded in building this transformational technology on a platform that has kind of nothing to prove. There are no exotic materials. There's nothing that's not known. One of the greatest compliments we've been given is that what we're doing is kind of boring. And that was exactly the point, to build units that would be dead reliable, dead safe, economical, and able to be taken to very large scale very fast.
So in this concept of storing heat for high heat industrial processes, how long can the Rondo heat battery technology store energy for, and what kind of temperatures is it stored at? And as a third part of that question is there, what does that mean that an industrial partner may need in terms of space or other resource, just as if they're thinking of a partnership around this?
Okay, thank you. That was three great questions. So one of them was, how long are we storing heat and how effectively are we storing it? Another is, how much space does it take? Yes. And what are the resources required? So the goal here is to drive an industrial process with continuous energy. You turn on the boiler, you turn it off a year later. It runs continuously for a year. You turn it off for inspection or when you do a plant turnaround. If we have a solar source, we have charging available once a day. So our task is to store energy for about 24 hours. And to do that effectively around the year, we need to build a storage system with 16 or 18 hours of storage. Part of the day it's charging and discharging at the same time when the sun is shining. Part of the day it's just operating from storage. For systems that are wind powered, we look at, okay, what are the wind patterns? Sometimes there are 2 wind peaks per day. We look at the variability of wind, and somewhere around that same number of hours of storage gets you on the order of 90% of your annual energy just from the storage unit. Now, there are seasonal variations and periods when there are storms or non-windy periods, and every industrial project that we're working on, a fuel-fired option is typically retained so that the reliability of the plant is maintained, but the annual fuel burn is reduced 90%. No one running an industrial facility gets to reduce his annual output quota or his annual reliability as part of decarbonization. Right? That is, in fact, one of the central challenges, is to make sure everyone in the organization today continues to meet their KPIs, continues to meet their key performance indicators on production and operating costs and all those things. And our design has been really shaped by experience with a large number of industrial processes in my previous career and my colleagues' previous careers. You mentioned space. We've designed this unit with the highest density, the highest energy storage per square meter of footprint of any technology. It's on the order of 4 to 8 times more energy stored per square meter than today's lithium-ion battery systems. But it has to be. That is, you can put your electricity storage, a mile away. Your heat storage has to be right where the heat is used. Now, that's maybe different with steam networks, but as we go to higher temperatures in particular, the density that you asked is really a critical matter. And another enormous matter is safety. If we're going into behind the fence within the industrial facility, we have to meet very high standards of safety. And again, using materials that have no possibility of combustion or release or spill of any kind has been instrumental in the acceptance and the enthusiasm we've seen from customers.
In any company in its early stages, I mean, I know there's a broad kind of industrial market that you could play into, but at this stage of development, are you more or less focused on any particular sector, or what's your view on that?
Yeah, thank you. That's also a really critical question, especially as an early company. The temperatures that are available from the Rondo unit are sufficient to serve more than 90%, maybe 92% of total world industrial energy use. At 1500 C, which is our current top temperature, that spans everything except processes like blast furnaces, where there are other pathways that are being used. So this is a platform that, again, whether you're making baby food or paper or glass or aluminum or cement, the same technology platform applies to all of them. And to your point about where do you begin, we've been focused on markets that we had developed a deep understanding of previously, but also markets where there is customer urgency with a technology that's based on these completely proven materials, but it's still a juvenile technology. The customers that we're working with today are those for whom what we're doing is economically transformative. My marketing guy likes to use the term desperate customers. I wouldn't say that. But it's, there are many sectors where that's true. And we focused on things close to home here. Our first units are going here in California, but today there are 100 projects in, I think, 9 countries right now. It is rather overwhelming. We are at a moment that has surprised all of us. The decarbonization of industry is a challenge that many folks are really moving towards solving and seeking solutions today. And that's even before recent geopolitical events, where the drive to move from imported gas to domestic renewables in European countries has never been higher.
For sure. I mean, obviously in Europe that we already had quite high energy prices, so it's kind of created even more urgency, I think, around finding alternative solutions. So you must be finding, I imagine, that the doors are slightly more open as you come up to them, and the conversations are slightly more open, given the current climate.
The doors have been open for sure. It's a sense of urgency. There's one thing where I'm planning to do this, and then there's another that I need to do this as fast as I can. We are seeing debottlenecking of the permitting processes for offshore wind projects that were planned. Can we move that project forward 2 years? Can we double its size? The transition to renewables powering industrial heat, it is a spectacular opportunity to make very big reductions very cheaply. The first term in that formula, though, is expansion of the electricity supply. A friend once said to me, why are all the factories, why are all the industries in the UK on the coast? Well, it's because where it was easy to bring the coal. It's also where the landing sites are for giant wind projects. There's a felicitous combination of large industrial heat demand and good renewable resource availability in many European areas. So that the thing that I think is changed is just the speed, and we're being asked by a number of folks, how soon can you do this? And of course, that's the task that we're working on.
Well, that kind of leads me neatly into the next core question, really, which is about the stage of development that you're at as a business and as a team. So where are you in the investment to scale cycle that disruptor technologies go through?
We started Rondo a little over 2 years ago and did really top to bottom look across all the different technical pathways, the there are many options that have been researched for many decades in how to do heat storage from this new perspective that the driving energy was going to be electricity. We went through many things, and by summer of last year, we were running prototypes. We'd made the fundamental decisions. This is the product foundation. We launched a fundraise that closed before the end of the year and brought in, from my perspective, dream team lead investors. Energy Impact Partners is a decarbonization fund whose backers are the electric power industry. Breakthrough Energy Ventures is a climate transformation fund that was put together by Bill Gates. And the two of them have a depth of both technical and market understanding that have been hugely helpful. And that fundraise was to take us from the lab to volume production. We'll be delivering over 100 megawatt hours this year of energy storage to paying customers. And the work this year will establish volume manufacturing capacity in place for volume deliveries beginning next year.
And so volume delivery, would that be a pilot scale project enabler, or is that already underway? You know, what are we looking at in terms of the project size that you're planning on this year into next year and after that?
The size of these industrial heat loads is, it means that you make no little units. Our base unit charges at a rate of roughly 100 megawatts and stores 300 megawatt hours and delivers 20 megawatts of heat continuously or 40 megawatts intermittently. We're in the process of announcing these units. So we're building these units now, and just one of these units is, I believe, more long duration energy storage than the electricity long duration energy storage industry has delivered in total. That sounds like a big claim, but given how simple what we're doing is, it's just, 1,000 tons of brick stores a lot of energy. So we are going to a scale that there is a pilot installation and first full-size commercial installation this year. And that will, the two of them will give us the references and the experience for then continuous commercial installations beginning next year.
Great. Well, we will definitely pull you back into the hot seat once you have that next phase of experience under your belt, because it's, as you say, you're entering this, you're in this space where industrials are actively looking for lower cost energy, decarbonization of as wider asset base as possible. And no matter what the kind of outside world may believe, this is increasingly driven by their own investors and not just waiting on policy. So you have an active marketplace. So it must feel like an exciting time to be kind of at this scale up point.
It is an exciting time. And to your point about this, and it goes back to what we were talking earlier about urgency. There are lots of folks who might want to say, oh, come talk to me when you have 80,000 hours of operating experience with somebody else. There are plenty of industrial facilities that are only updated or turned over once a decade or on a longer time horizon than that. And we are today in a moment where the combination of the absolutely desperate, urgent drive to decarbonize industry, literally to save the planet, investors pushing that, but also has been driving lots of action for sure. The thing that I think is driving even faster is, as we talk to people, the decarbonized future is lower cost than business today. Bill Gates likes to talk about the green premium, that we're going to have to do things that are more expensive for a while to make this transition through the energy transition. And in what we are doing, again, because what has happened with wind and solar, the green premium is history. And so it's a perfect storm if we have the existential urgency for the planet, immediate market recognition that driving this transition is a core corporate goal and value across the entire industrial sector. And here's a pathway that's lower cost than business as usual. So that as I drive through this, I'm no longer having to make this choice of how quickly do I decarbonize, but what's the negative impact on my earnings report? It's the other direction. So with those things lined up, we will see, giant private capital flows driving the energy transition more rapidly. And that was our key goal in that Rondo.
Well, I think that's as strong an ending to a podcast we've had so far, because that box of how do we do this? Is there a business model? Can we afford it? It's actually going to be cheaper. Well, that's the kind of the holy grail that everyone's been looking for, isn't it? So good luck with the scale up this year. And I'm serious, we'll need to bring you back when we can get that sort of next phase pilot up and running and hear how that goes at that stage.
Thank you so much. If I might add one thing, we are growing very rapidly. We are urgently hiring across the company. And if your listeners have interest, we have a spectacular internal culture and are looking to build this team very rapidly. So I just wanted to put in a plug for, we're looking to grow the team.
Well, plugs for climate careers are always welcome. So we'll actually in the show notes, we'll add links obviously to Rondo and to any links you want us to share, John, but we could also add a link to any careers page and information that you want to share as well.
Thank you.
Great. Thanks again.
Pleasure.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.